Here's problem 1422. The siphon shown is used to transfer liquid from a higher level to a lower level. If the fluid is drawn up and is continuous through the tube, determine the velocity of the flow of gasoline if the vertical distance from the liquid surface to the outlet is 1 meter. So we have a contained fluid if it's continuous. If there's no gaps in the fluid, then we can consider this with Bernoulli's equation. And hence, we will look at 2 points on this fluid. One point is the point that's open to the atmosphere at point A, and the other one is also open to the atmosphere at the opening down here at point B. So as we consider these 2 points, we have Bernoulli's equation, the absolute pressure at A, plus 1/2 the density of the fluid times the velocity at A squared, plus the density times G times the height at A. This is the kinetic energy per volume and the potential energy per volume for the fluid is equal to the absolute pressure at B plus the kinetic energy per volume for the fluid at B plus the potential energy per volume at point B. Alright, well, point A is open to the atmosphere, so we have an absolute pressure bearing down of 1 atmospheric pressure. And same thing at point B. Point B is open to the atmosphere, so the absolute pressure at point B is also atmospheric pressure, and those will cancel out on both sides. We also have that we can define our level at point B as being our zero height. So that would make our height at point B 0, and that would make our height at point A simply equal to h, where h is this distance between point A and point B, which is defined to be 1 meter. So even though the siphon goes higher, we are only considering these 2 points A and B within the continuous fluid, and that's all we need to know. So we have that, and also in our reservoir, our velocity at A is not going to be moving that much because it's a large reservoir, and so as we have flow out at point B, A is barely moving, and hence the velocity at A is basically 0. So we're left with this, rho GH is equal to 1/2 rho velocity of B squared. The density of the gasoline is going to cancel out on both sides, and now we're left with the velocity of B is the square root of 2GH by Bernoulli's equation by conservation of energy. And in this case, that'll be 2 times 9.8 times 1 meter squared, and that's equal to 4.43 meters per second. So in general, if we start from 0 and we go down to a lower height in a fluid, our velocity at that lower height is going to be indeed the square root of 2GH by Bernoulli's equation, and we just solved it fully in this particular problem.